everyone. Today we are going to be talking about how to draw correct Lewis structures. So, before we begin, I would want to talk about what we need to remember while going into solving these types of problems, because there are important aspects of this that we need to know. To begin, this symbol right here, this dash looking thing, goes in between two elements and it represents two electrons. These dots right here, each singular dot represents one electron, but the two of them together represents two. And generally speaking, there are usually pairs of two, but not always. Another thing to remember is that in a situation where there's a charge, positive or negative, on a ion like this, there will always be brackets around the side. And we need to remember that, because if you don't put the brackets, you could be potentially getting a problem wrong. And I just also wanted to remind you guys of how to find how many electrons you need to put around a Lewis structure, like in this situation. So if we look at the periodic table, I have it listed right here, how many electrons goes with each group. So, for example, Cl is right here, underneath 7. So we know if there was one Cl, there would be 7 electrons that need to be around it. So in this situation, it's Cl2. So since there's two Cl's, 7 plus 7 equals 14. So we know that there needs to be 14 electrons around this set. So we have 2, 4, 6, 8, 10, 12, 14. So this all adds up. And the last thing I want you guys to remember is that there needs to be 8 electrons around each singular element, which in this situation there both is, because there's 2, 4, 6, 8 around this one. And then there's 2, 4, 6, 8 around this one. And lastly, you should also remember that this can be shared in between both of these as well. All right, so I've prepared 3 questions for us to work on in order to get a better understanding of Lewis structures and how they work. So to begin, they want us to draw a Lewis structure for carbon dioxide. And we know carbon dioxide is CO2. So I want to start with drawing the general shape of CO2 and their Lewis structure. So CO, and I'm not taking angles into account for this because I think that comes a little farther down the process. Next, I want to figure out how many electrons should be surrounding this structure. To do that, I want to look at right here. We know that there are 2 oxygen atoms, which each have 6 electrons around them. So we can write 6 plus 6. And then we know there is 1 carbon atom, which has 4 electrons around it. So plus 4. And 6 plus 6 plus 4 equals 16. So around this, we should have 16 electrons. And we know that here there are already 4. 6, 8, 10, 12, 14, 16. You'd think that we'd be done at that point, but we're not done yet, because we need to remember to satisfy the octet rule, which means that there needs to be 8 electrons around every atom. And in this case, there are 2, 4, 6, 8 around this oxygen, and 2, 4, 6, 8 around this oxygen, but there are only 4 around this carbon. So in order to change that, we want to make these single bonds become double bonds. And we will do that by, I'm going to erase 2 electrons from both sides. and I'm going to make both sides double bonds. Now let's see now if it has satisfied the octet rule. There are 2, 4, 6, 8 around this oxygen. There are 2, 4, 6, 8 around this oxygen. And there are 2, 4, 6, 8 around carbon. So this should be what CO2 looks like after you've drawn the Lewis structure for it. So question 2 wants us to draw a Lewis structure for water. We know that water is H2O. Before we get into it, I want to remind us that hydrogen only needs 2 electrons around it to satisfy it. So when we're drawing the Lewis structure, it should look something like this. Again, not taking into account bond angles, but let's now look at the periodic table to see how many electrons we should have around this structure. So for hydrogen, there's only 1. So let's go electrons. We need 1, but there's 2 hydrogens, so 1 plus 1. And then for oxygen, there are 6. So we add another 6 equals 8 electrons needed around this Lewis structure. So after looking at it, we know that there are already 2, 4. And since we know hydrogen only needs 2 electrons around it to be satisfied, we don't put any dots around it like that. Whoops. We don't put any dots around it right there. We want to put them around oxygen. So we have 4 left, so 2, 4. And now we've used all the electrons we can, so let's make sure that the octet rule and the hydrogens are all satisfied. This hydrogen has 2 electrons, which means it's satisfied. This one does as well, and oxygen has 2, 4, 6, 8 electrons, which means it's satisfied as well. So this should be what your general Lewis structure for water should look like. Question 3 wants us to draw the Lewis structure for ammonium. We know ammonium is NH4 with a positive charge. So to begin, we want to start by drawing the general Lewis structure for it, which looks something like this. So we got to figure out how many electrons we need to go around this Lewis structure. And to do that, we're going to look back at the periodic table where we see nitrogen needs 5. So to keep count, we have 5 for nitrogen, and then each hydrogen has 1 electron that needs to be, or that it supplies. So we would be adding 4. That equals 9, but since there's a positive charge on ammonium, we have to subtract 1 from the amount that we can use around it. So the total would be 8. So let's look and see how many are around it right now. There are 2, 4, 6, 8 electrons already in this Lewis structure. So it looks like we could be done right now. But first, let's double check that every rule is satisfied. And to remind you, hydrogen should have 2 electrons, and nitrogen needs to be satisfied by the octet rule, which means that it needs 8 electrons around it. So let's look at hydrogen. Each hydrogen does have 2 electrons by it, so those are all good. And this nitrogen has 2, 4, 6, 8, so this is good too. Now, So it looks like we should be done, but we aren't, because we need to remember if a compound has a positive charge, we need to account for that by putting brackets around it with the positive or negative charge on the outside. So this is what the answer should look like, and you have to remember the brackets and the charge, otherwise you could definitely get it wrong.